Yesterday, as we started chapter 11, our focus was on fundamental counting principle, factorials, tree diagrams, and permutations. Today we switch gears and look at combinations. And a combination is going to be that grouping of terms in which the order does not matter, whereas yesterday with a permutation, order did matter. There are generally going to be fewer ways to select items when order does not matter. So for example, there are 6 ways to order 3 items, say like called A, B, and C, with ABC, ACB, BCA, CAB, CBA, and BAC. But they are all the same combination of A, B, and C together. And when deciding whether to use those permutations or combination, you need to decide if order matters. If yes, it's a permutation. If no, it's a combination. If you decide it's a combination, the formula we're going to use today talks about the number of combinations being equal to the ways to arrange all the items divided by a product of ways to arrange the selected items times the non-selected items. In other words, a combination of n items chosen r at a time would be n factorial divided by r factorial times n minus r factorial. So if we put this to use, we have here that there are 12 different colored cubes in a bag. How many ways can Randall draw a set of 4 cubes from the bag? And what we mean is it doesn't matter what order we draw the cubes, because if we draw a pink and then a purple and then a black, or a black then a purple then a pink, it doesn't matter because it's still a black, a pink, and a purple marble. So therefore, if we have a combination, we have 12 cubes and we're choosing 4 of them at a time. So this is our n. Our 12 is our n, and our 4 is our r. So therefore, when we put this into the formula, it's going to be 12 factorial over 4 factorial times 12 minus 4 factorial. If we simplify this out, it gives you, it's 12 factorial divided by 4 factorial, and then 12 minus 4 is 8. So 8 factorial. If we expand this out, we have 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all over 4 times 3 times 2 times 1 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. The first thing that I notice is that 8, 7, 6, 5, 4, 3, 2, 1 can cancel. And then I start saying, well, if I take 4 times 3, I can knock out the 12. And if I divide by 2, 10 goes to 5. And now I'm down to only a 1 in the denominator, which means that all I have left to multiply is 11 times 5 times 9, which is a whole lot easier to do. So if I take 11 times 5 times 9, I get 495 options or ways. And if I wanted to go back to check, I could do 12. Remember, we have the math button. We're going to arrow over to probability and hit 4 for factorial. And we're going to divide that by 4 factorial times 8 factorial. And the one thing we need to make sure we do is go back in here. The nice part, if you hit second delete, it'll insert, and we need to put a parenthesis in, and then it doesn't delete everything out that you already have. We'll put a parenthesis in there, we hit enter, and we still get 495. Trying another example. Our team has 8 swimmers. 2 swimmers will be selected to swim in the first heat. And how many ways can the swimmers be selected? If we write this out, this is a combination because whether they choose George and Bobby or whether they choose Bobby and George, it's still the same 2 swimmers for that first heat. So we have 8 swimmers, chosen 2 at a time, which will be 8 factorial divided by 2 factorial, and if you wanted right away, jump to 6 factorial, as long as these 2 numbers here add up to your numerator. Doing that, I know that this is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Divided by 2 times 1 times 6 times 5 times 4 times 3 times 2 times 1. I can cancel out the 6, 5, 4, 3, 2, 1. And I also see that I can cancel the 2 with the 8 and make 4. So I see that I have a 4 and a 7, and that gives me a final answer of 28 wings. Now, how many combinations of the letters in the word truck can be taken 2 at a time? I know that this is a combination because it tells me. Combination. Truck has 1, 2, 3, 4, 5 letters, and we're taking them 2 at a time. That's 5 factorial times 2 factorial, 3 factorial. And then if you wanted to jump to this and say, well, I know that the 3 factorial is going to cancel, and that will leave me with 5 times 4, because 3 times 2 times 1. And then I can look at and say, well, 2 will cancel 4 to make 2. That means I have 10 combination or combos. Now, the second piece is using the calculator. I realize we've used the calculator with the factorial, but I want to use actual for the permutation and combination. We talked about permutation yesterday. So we're going to look again for that math key, and we can arrow over to PRB, and we talked about the NPR permutation button. Now number 3 is the NCR, and we talked about factorial yesterday. So once you've done that, remember the N must be done before the value. So I'm going to quit out of there, and if we take a look at an example, say we go back up to C. We have 5 items, and I'm going to then go to the combination, which is the third option, and we're taking them 2 at a time, and it gives me 10 for an answer. So remember that you must enter your value for N before finding the NCR or NPR in the calculator, because otherwise it doesn't interpret the N value. Your job now is to try these 2 U-Try problems, enter them into Edpuzzle, and bring your questions with you to class tomorrow.